guys, how are you today? So today I'm going to be explaining the chapter 2 course revision questions from 2.3 until 2.4 only, because that's the only thing we have. So anyways, without further ado, let's get started with the first question. 1 grid. A cannonball is launched at 37 degrees, this is theta, above the ground with an initial speed v0 of 25 meters per second, and assumed drag is negligible, meaning no friction, no air resistance, and g is 9.8 meters per second squared. Calculate the greatest height. What's the greatest height? H max. So we need to find the greatest height, H max. What's the equation of H max? It's v0 squared sine squared theta over 2g. So it is 25 squared times sine 37 squared over 2 times 9.8. 25 squared times sine 37 squared over 2 times 9.8. That's going to be what? That's going to be 11.5 meters. Perfect. Now, part B. What do they want from us? They want the smallest speed of the ball as it moves through the air. Now, honestly speaking, the smallest speed is only going to be the Vx. Why? Because when you're finding the speed, it's usually radical Vx squared plus Vy squared. But there's a certain point, which is over here, where Vy is what? Vy is 0. So at this specific point, we'll only have the speed of x, Vx, and this will be the place where the smallest speed takes, like where the smallest speed is found. So at H max, this is where the smallest speed of the ball is. So how do we find it? You just need to find Vx. So it's the equation of Vx. It's V0 cosine theta. So it's going to be what? It's going to be 25 times cosine 37, so it's 20 meters per second. This is the smallest speed. Now part C, calculate the range of the ball. How do we find the range of the ball? What's the equation of the range? It is V0 squared sine 2 theta over g. So 25 squared sine 2 times 37 over 9.8. So 25 squared times sine 2 times 37 over 9.8. How much is this going to give me as an answer? This will give me 61.3 meters as the range of the ball. Question number 2. The diagram below shows the projectile motion followed by a cannon shell. Assume upward as the positive direction. What does this mean? This means upward is the positive velocity and downwards is the negative velocity. Okay, so graph the horizontal displacement x and the vertical displacement y with time. Okay, so they want the horizontal and vertical displacement. So we know that the velocity Vx is what is constant. That means if here is x and here is the time t, it will be a constant line passing through the origin. Whereas for y, Vy varies, right? And it will and Vy takes the shape of how it's moving, right? So it will start from the origin. Here is y, here is t. It will start from the origin, it will increase, and then it will decrease. So it will look something like this. So this is for part A. What about part B? In part B, they want us to graph the horizontal and vertical components of the shell's velocity with time. So you can just graph one single VT graph. They want the horizontal and the vertical components. We first start with the velocity time graph. They said it's upwards, meaning the velocity is upwards, meaning it's what? It's positive, right? So since the velocity is positive, we first start with Vx, which is constant, to be upwards, positive. And then Vy, what's the equation of Vy? Vy equals minus gt plus V0 sine theta. As you can see, V0 sine theta is where it starts, which is over here, because they both start from the same, or actually not necessarily the same, it could be over here, for example, right? And it will go down because the slope is negative. So this is what the graph looks like. Now, it says, how does the magnitude of the acceleration of the shell vary with time? Now, first of all, they mentioned magnitude, so whatever answer we take, it should be positive. Now, Ax is always equal to 0 because velocity is constant on the x-axis, but on the y-axis, Ay is minus g. Now, you take this in absolute value, it's going to be g. Now, what's the acceleration of the shell? It's gonna be very simply 9.8 meters per second squared. Now, this is one singular value. There's no x, t, there's no variable. So because of this, we say that it's constant. It does not vary, it does not change. We move on to question number 3. Compare the ranges of a projectile shot with the same initial speed at 30 degrees, 50 degrees, and 70 degrees. So they want us to compare the ranges. What's the equation of the range? Equation of the range is v0 squared sine 2 theta over g. Now 2 theta is the most important part. The maximum angle you can have is 90 degrees. So the maximum theta we can have in the projectile motion is going to be 90 over 2, which is 45 degrees. So 45 degrees is the basis. It's the maximum. The farther away you go from it, the smaller the range. But the closer you are to 45, the larger the range. So 30, we have 30, 50, and 70. Right? 70 is, how far is it from 45? It is 25 away from 45. And 50 is 5 away from 45, but 30 is 15 away from 45. So in order, it's going to be R70, then R30, then R50. So you just need to see which one is closer to 45. It's going to have the greatest range. Now, a rock is launched from ground at 10 meters per second at an angle of 53 degrees with the horizontal. Okay, V initial, theta. Take g equal 10 meters per second squared. Calculate the time the rock is airborne, the horizontal distance the rock travels, and the maximum height the rock reaches. So first of all, we need to find the time that the rock is airborne. Now, what does this mean? Time rock is airborne is basically time that is ground, right? So t ground or t same level initial. So what's the equation? It is 2v0 sine theta over g. So it's gonna be 2 times 10 times sine 53 over 10. So that's gonna be how much it's gonna be? 1.6 seconds for part A. For part B, the horizontal distance that the rock travels. The horizontal distance that the rock travels is the range. So what's the equation of the range? Very simply, equation of the range is v0 squared sine 2 theta over g. So basically, you put it on the calculator, substitute all the values, you will get 9.6 meters. Now, the maximum height that the rock reaches, h max. How do we find h max? We go back to the equation. Where is the equation of h max? It's v0 squared sine squared theta over 2g. You substitute all of the values, right? So 10 squared times sine 53 squared over 2 times 10. That's going to be what? That's going to be 3.2 meters. Now part D, assuming the initial speed of the rock remains the same, at what angle with the horizontal should the rock be launched to achieve a maximum height and the longest time airborne? How do we achieve a maximum height, the longest time airborne, and a maximum range? Maximum height theta is supposed to be 90 because always the maximum is supposed to be 90, right? And here it's supposed to be 90, but here the range in the equation it's sine 2 theta, meaning theta should not be 90 because then if you put it as 90, it's going to be 180. We don't want it to be 180. We want it to be 90. So instead, what we do is we put 45. We move on to question number 5. A wooden ball is projected horizontally from the shelf of a height 1.8 meter as shown in the figure below. The ball lands on the ground at the horizontal distance of 120 centimeters from the bottom of the hill. Use G as 9.8. They want the time it takes the ball to reach the ground. Here, in this scenario, theta is 0. Since theta is 0, we cannot use t ground. We cannot use h max and we cannot use r max. So what equations will we be using in order to find the time that it will take the ball to reach the ground? We have the value of delta y. Delta y is minus 1.8 meters, right? So using the delta y equation, because we also have g as well, using the delta y equation, we will be able to find the value of t. What is the equation of delta y? Delta y equal minus half gt squared plus v0 sine theta t. Now, since theta is 0, because it's being dropped, okay, it's thrown down, it's being dropped, theta is gonna be 0, so we directly remove this and we're left with this. So that means minus 1.8 equals minus half 9.8 t squared. Minus and minus go. T squared equals 1.8 over half of 9.8. And how much is that gonna give me? That's gonna give me as an answer 0.37 or 0.367. Now, how do we get rid of the square? We need to do radical here and radical here, so we will get the time t to be 0.61 seconds. We move on to part B. Calculate the speed with which the ball was launched, and this speed is u. How do we calculate it? Very simply, what can we find over here? Over here we have delta x, and we have this is delta x, and we also have delta y. So what is the equation for delta x? It's v0 cosine theta t, right? Delta x equal v0 cosine theta t. Now, cosine theta, since theta is 0, it's gonna be 1 because cosine 0 is 1. So we're now left with delta x equal v0 t. Delta x is 120. The time to reach the ground was how much? Was 0.61. Now, of course, you need to change this from centimeter to meter, so 1.2. So v0 equal 1.2 over 0.61. So that's supposed to be 1.96, which is approximately 2. Now we have what? We have Vx, which is V0 cosine theta. So it's gonna be 2 cosine theta. 0 is theta, so it's gonna be basically 2. Now they want us to calculate the magnitude of the velocity. We need to find Vy. Vy is minus gt plus V0 sine theta t. We have v0, which is 2, but theta is 0 and sine theta is 0, and anything multiplied by 0 is 0. So now vy equal minus gt, so minus 9.8 times 0.61, so minus 6. Now we can find the magnitude by doing radical 2 squared plus minus 6 squared. So this is supposed to give us an answer of 6.3 meters per second. Now they want what? They want the angle theta. So it's tangent inverse y over x, so minus 6 over 2. So tangent inverse minus 6 over 2. So that's gonna. So basically, the answer key is wrong. The answer is supposed to be minus 71.6 degrees. Of course, you could put it like this, or you can add minus 71.6. You can add to it 360, and you'll get 288.4 to get a positive answer. So whatever they said is wrong. It's not 76, it's 71.6. We move on to 6th top question, and then we reach, okay. A steel ball is projected from a catapult from the horizontal ground towards a target on the vertical wall. The ball has an initial velocity of 10 meters per second at an angle alpha to the ground. So the initial angle alpha or theta, the ball travels a horizontal distance of 4.2. That means delta x equal 4.2 before striking the wall at height h above the ground. The horizontal component of the UH is the initial velocity of the ball. Oh, they're saying the horizontal component of the initial velocity of the ball is 8 meters per second, and we need to use g as 10 meters per second squared. They want the time t that the ball is in flight. So what can we say? They want us to find the time t that the ball is in flight. What we could do in this scenario is we could use the delta x equation. Delta x equal v0 cosine theta times t, right? Delta x is how much? They gave us delta x to be 4.2. Then they told us that the horizontal component, which is this value, which is vx, okay? v0 cosine theta is vx, is 8 meters per second. So we can substitute it by 8. So now t is 4.2 over 8, which is 0.53 seconds. Let's make sure they didn't do any calculation mistake as well. So yeah, 0.53 seconds. Now calculate the vertical component of the initial velocity of the ball. Okay, in order for us to calculate the vertical component, meaning they want Vy, in order for us to calculate it, first of all, it's gonna be minus gt plus Actually, no, they did not use this long, big process. Instead, they found V0y. V0y, because it's the vertical component, is V0 sine theta. So we need to find theta. We know that 10 cosine theta is equal to 8. So cosine theta is what? Is 8 over 10. So theta is cosine inverse 8 over 10. What's cosine inverse 8 over 10? It is 37 degrees. That means theta is how much? Theta is 37 degrees. Okay, so now I can substitute it here. So 10 sine 37, this will give me my answer to be how much? To be 6. So the vertical component of the initial velocity is 6 meters per second. Now determine the value of h, okay? Now h is what? H is delta y, right? What's the equation of delta y? It's minus half gt squared plus v initial t, or v0 sine theta. Whoops, I don't know what I keep on doing. Sine theta t. So delta y, which is h, is equal to minus half of 10, so minus 5 t squared, plus v0 sine theta t, so plus 10 sine 37 times t. Now we found t in the first part. How much was t in the first part? It was 0.53. So we'll substitute it over here by 0.53. 0.53. Okay, so delta y is minus 5 times 0.53 squared plus 10 sine 37 times 0.53. So all in all, it should give us our answer to be 1.8 meters. Again, they did a calculation mistake. They forgot to square the time. Pay attention in the answer key. So now we'll move on to part B. What does it say in part B? On the axis, show the sketch of the variation of the vertical component of the velocity of the ball with time from the instance it's launched to the instance t where it hits the wall. They want the vertical component of the velocity, so Vy. Honestly, it starts at a specific point over here, and then it just keeps on decreasing because of the equation Vy equal minus gt plus V0 sine theta. Now, it starts at an initial point, V0 sine theta, and then it just decreases. That is it for part B. We'll move on to section 2.4, and then I will finish this video and I'll do the next one. Relative motion, 7G. A motorboat is in a river at 6 meters per second due north. The river is flowing at 2 meters per second due east. What is the speed? When you have it like this, you need to do the parallelogram method, and then you need to connect tail with tail, head with head, and you will get a right triangle. And what do you need to do? You will need to find the magnitude. So radical 6 squared plus 2 squared equals 6.3 meters per second. Okay, define relative velocity. If they asked us to define relative velocity, it would be first by giving an example. I'm not gonna write it, I'm just gonna say that the relative velocity of an object B relative to an observer A, this is what you write. Relative velocity of object B relative to observer A is the velocity of B measured in the rest frame of A. So very important. Define relative velocity. It is the relative velocity of an object B relative to an observer A is the velocity vector of B measured in the rest frame of A. We move on to B. A drone is flying horizontally on a windy day. Figure below shows the velocity vectors to scale for the wind and the drone flying in still air. The velocity of the drone in still air is 10 meters per second due west. The velocity of the wind is 4 meters per second in the direction of 37 degrees east of north. They told us, complete the diagram to show the vector representing the resultant velocity of the drone. How do we do that? We just draw the parallel lines. That was not parallel. We need to draw the parallel lines, right? And then what do? We'll connect the tail with the tail and the head with the head, and this is our resultant force. And over here, because they are parallel lines, according to the alternating angle theory, actually we cannot say anything because we don't know what's the full angle of this. It's only this angle over here, so I'm just gonna leave it aside, okay? Whatever they said in the marking scheme, for some reason it's all wrong in this section. Anyways, we'll move on. My bad. The velocity of the drone is still in air, 10 meters per second. This is V0. The velocity of the wind, oh sorry, no, let us see. They told us due west 10 meters per second. north 4 meters per second and the direction is 37 degrees. Complete the diagram to show the vector. Okay, now determine the magnitude of the resulting velocity vector. How do we determine this magnitude? Very simply, before we do anything, we will need to resolve this one over here because it's at an angle. So we need to make its x and its y. How do we find the x and the y? The angle is over here. The y is adjacent to the angle, so the y is gonna be 4 cosine 37. The x is opposite to the angle, so it's gonna be 4 sine 37, right? So this is y, this is x. And now what do? We need to add and subtract. So we do 4 cosine 37, there's nothing to add and subtract, and then 10 minus 4 sine 37. So that's gonna be 7.6, okay? So it's gonna be radical 4 cosine 37 squared plus 10 minus 4 sine 37 squared. Okay, I need to square everything. Here, for 4 cosine 37 squared plus 10 minus plus 10 minus 4 sine 37 squared. And what will we get as an answer? And we will get an answer, which is 8.2 meters per second. So that's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful